Okay, now we're going to talk about the pancreas. So we've done the adrenal glands. We've done the pituitary, the thyroid, the thymus, and the pancreas is now we're now here. So this is the pancreas down here. So this is it. You can see it. This end, that end is going is there's a duct that leads into the small intestine, and that's the head is down this end. So this end is all the head, and then the rest of it goes around. Oops, like this. Here, that's the tail, and this is the body, like that. So there's your pancreas there. And so we got the liver, we got the stomach reflected, so it means it was pulled back up, so that you can see underneath, because the pancreas is on the back underneath the stomach. So you have the stomach sitting here, and the pancreas is back behind. Well, I'm sure. Oh yeah, I'll do this. So the stomach is here, and the pancreas is back behind it. So that gives you the orientation there. All right, next slide. So what is the pancreas? You saw what it looks like in the cadaver there. It's an exocrine gland as well as an endocrine gland. So what is exocrine? Exocrine means that it's secreting stuff into ducts. And that happens through cells that are called acinar cells. They secrete digestive enzymes which go into the small intestine via ducts. So you have all these acinar cells, and they all have ducts coming off of them, and that they all converge, and then there's a duct that goes into the small intestine. Actually, a bile duct from the gallbladder comes in and connects to it right before it goes in the small intestine. And so there's your pancreas, and then here's the head here. So there's a head. I was circling the head, pancreas, body, and the tail of the pancreas. And so here's the acinar cells here, and you see they're glandular type cells, and there's this hole in the middle with all these cells grouped around it. That's the duct, and then those ducts all eventually come together, and they make one long duct coming out of the pancreas. So that's the exocrine. That's the exocrine function of the pancreas, is producing digestive enzymes. Most of the cells that are in the pancreas are the digestive enzyme cells. There's other cells in there that are called alpha, beta, and delta cells. So the alpha cells, beta cells, and delta cells up here. And those are all found in what are called islets. So we have pancreatic islets. These used to be called islets of Langerhans, and lots of times you'll hear people use that word. Either one works. These regulate blood glucose levels. So alpha cells make glucagon, which raises blood sugar levels. You trigger release of glucose from glycogen in the liver. So your liver takes glucose and it sticks it together in a chain to make glycogen. And so glucagon triggers glycogen breakdown. So then you release glucose. The beta cells produce something called insulin. I'm sure everybody's heard of insulin. This lowers blood sugar levels. It stimulates by stimulating body cells to take up the glucose. It also stimulates the liver to convert glucose to glycogen. So the glucagon and insulin are working against each other. So glucagon says break down the glycogen. Insulin says, hey, liver, make glycogen. Take all the excess glucose that we have and store it, because we might need it later on. So your body's really good at taking things that you've eaten and then storing them for later, saying, oh, I might need this, so we'll keep on to it. We'll hang on to it. So you store it as glycogen in liver, and you also store it as fat. So you get both things happening. Glycogen is breakdown is a really easy way to access glucose, which is a high energy molecule. You get a lot of energy out of that. Fat breakdown takes longer, so I run marathons. So what happens is around mile, it depends on how you train sometimes in your personal yard, but somewhere in the range of 18 to 22 miles, people report hitting the wall. And I actually experienced this about mile 22. I was chugging along. I'm like, yeah, this is great. I'm going to have a great time on this. And all of a sudden, I just slowed. And I couldn't figure out why. And what happened was I'd switched over from using glycogen. I'd used up all my glycogen stores, because you got about 2 hours of that. And then after that, you start using fat. Well, fat breakdown just takes more energy and is a slower process to get energy out of it. But you have enough fat to last you a long, long time. You only have glycogen stores to last a couple hours, but I could run on my fat stores for literally weeks. So anyway, delta cells make something called somatostatin, and this is identical to the somatostatin, the growth hormone inhibitor that is secreted by the hypothalamus. So somatostatin, somato meaning body, statin meaning stop things, so it stops things. So that's a growth hormone inhibitor. So alpha cells are glucagon, beta cells are insulin, delta cells are somatostatin. All right, next slide. Well, let's see, hold on a second. I'll just show you the drawing of pancreatic islet. Here's the pancreatic islet, and so here it's very easy to see here all the way around this. Here's an islet having alpha, beta, and delta cells in it. And these cells are all ACE and R cells, all out through here. So ACE and R cells. All right, next slide. Here's a little bit higher magnification of all this. And so we have the ACE and R cells surrounding, you have surrounding a duct, and then you have the pancreatic islet here. Islet meaning little island. That's what islet means. So we have the head of the pancreas again, the body of the pancreas, and tail of the pancreas. This is an artery on the outside. If you chop open the pancreas, you'd see the duct, the main duct going down the middle of it. Next slide. So here are pancreatic islets, or the islets of Langerhans. Here's another one here. Here's some ducts. There's a duct there, and there's another duct there. So those are, and here's another one down here. Those are ducts. Here's another one over here. So there, and you have ACE and R tissue. That's what all of this is, all ACE and R tissue. So you can see, when you look at this, you're like, oh, there's a lot more ACE and R tissue than there is pancreatic islets. So so you have to, and I put up a movie about, that's posted about looking at the endocrine system, how it's discovered, and things about that. It's really interesting documentary, and it's kind of it's interesting to watch. It's not boring, and so I'd encourage you to watch it if you get a chance. If you don't get a chance, put it on the to-do list. So anyway, so you have pancreatic islets, or islets of Langerhans, pancreatic islets. You also have ACE and R tissue, and you have the ducts, the ACE and R ducts. So next slide. Here's the ducts again, just a little bit, it's a little bit easier to see there. ACE and R tissue, you see all the cells, and the pancreatic islets. There's one here, there's one here, 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 and there's another one over here. So there you go. All right, next slide. And here we go. You can see the pancreatic islet very well here in the center, all the way around there. So, and then ACE and R tissue, ACE and R cells in there. Next slide. Here's one more. I'm not sure. I don't think I have too many more of these. So here's a duct there. Then you have a pancreatic islet. Here's another duct. Here's another duct. Here's another pancreatic islet over here. And this is all ACE and R tissue. But you can see all the rest of that. All right, and this would be another islet down here. And this is another one over here. So just so you can see those very easily. So it's mostly ACE and R tissue, but there are these islets in there. So you're making glucagon, insulin, and somatostatin. So the alpha, beta, and delta cells. Next slide. So here's a higher magnification pancreatic islet, the duct, and you can see the epithelial cells lining around there, and then you have all this ACE and R tissue. So all that digestive enzymes are all being made there, and they break down proteins, lipids, and sugars. So all the digestive enzymes, and they're wrapped in a little baggie, I guess, and as they go down the duct, so it doesn't digest things as it's going along until it gets to the stomach, and when it gets to the small intestine. When it gets to the small intestine, then those open up, those proteases and lipases and amylases are all released and they break down. Amylases break down sugars, and lipases break down fats, and proteases break down proteins. So next slide. I got another picture of the pancreas. Okay, pancreatic islet, acinar tissue, and a blood vessel over there on the right side. So, all right, next slide. And one more. I took a whole bunch of these out of the online stuff. So, the Pearson online. So there's your pancreatic islet again. I'm not sure. I don't think I have any more of these, but you can see the acinar tissue and how it would all its digestive enzyme products could come out of that and go down the ducts. All right, next slide. Okay, so we're down to the reproductive system, so we're almost done. So you have the testes and ovaries. Testes are for gamete production, as are the ovaries for gamete production. Testes produce sperm, ovaries produce egg cells. And testes also produce testosterone. Ovaries produce progesterone and estrogen. So the testes produce testosterone. That makes it pretty easy to remember. And ovaries produce progesterone and estrogen. So the book makes reference to something that the woman who wrote the book called the hypothalamic hypophyseal testicular axis, which I found very interesting. So I'll talk about that in a second. So you have the hypothalamus releasing gonadotropin releasing hormone, GnRH here. Okay, so hypothalamus releases gonadotropin releasing hormone, which acts on the pituitary, causes the anterior pituitary to release luteinizing hormone and follicle stimulating hormone. Okay, now luteinizing hormone acts on the testes and stimulates testosterone production, which stimulates spermatogenesis and is also responsible for secondary sex characteristics. And you may have noticed I shaved off my beard, which is kind of, I guess, it's sort of weird in a way that I did that for the endocrine lecture, but hey, that's what I did. So as it's starting to get, after a couple months of it, gets annoying. But anyway, so let's see. So, and FSH, follicle stimulating hormone, acts on the testes to stimulate sperm development. So it stimulates. So you have luteinizing hormone stimulating testosterone secretion. So you start making sperm, and follicle stimulating hormone acts on testes to stimulate the further development of the sperm. So, and luteinizing hormone also so stimulates testosterone, so you get secondary sex characteristics for males. So we got that. Now ovaries, follicle stimulating hormone stimulates the gamete formation, just like it does in the testes, and it stimulates secretion of estrogen from developing follicles. So you have a follicle and it releases an egg. So you have secretion of estrogen from that. Luteinizing hormone stimulates the production of progesterone and estrogen, which are responsible for secondary sex characteristics in women, and also for the female reproductive cycle. So what I found interesting was that in the book, she referred to the hypothalamic hypophyseal testicular axis. And I was surprised because why didn't she refer to it as the ovarian axis? And I thought it'd be interesting just to point this out to you guys. There's all kinds of subtle things that you'll hear over the years, and so just keep your ears open for these kind of things. Medicine was dominated by men for a long, long time. Things have changed significantly, but for instance, when I was looking, years back when I was looking at med school and all that kind of stuff, it was very common for women to if they applied, it was assumed that they were going to be either pediatricians or obstetricians, and that was basically the two roles that they were going to assume if they got an MD. So things have changed a lot since then. But I just found it interesting. The woman who wrote the book wrote this in this way. This is an old way of thinking about things, because the hypothalamus and hypophyseal axis includes both the testes and the ovaries. So it actually goes for both ways. I'm not sure why she referred to it in this old sense. But you may hear words like this, and this does affect the way that you view things. And so you view it as the hypothalamic hypophyseal testicular axis, and you'll think, oh, women are secondary, and ovarian is just, women are just little men. And that's the way medicine was done for a long time, was women were just men, but just smaller. and that's not true. And so there are distinct differences. There are distinct things that happen between men and women, and we've talked about a few of those like over the course of the semester. But anyway, I thought it was an interesting thing. I just wanted to point that out. All right, next slide. So here's where the testes are, and so it shows you one there along with the penis, and there's epididymis right above the testis there, so you can see the epididymis there. This little part sitting right up here. Okay, all right, and the testis sticking out there, round structure there. Okay, next slide. This is the ovaries, and so we have the right ovary way down, so we're looking directly down into the pelvic cavity here. So this would be the pubic symphysis would be here. Okay, so this is the uterus here. Coming across here, I'm not drawing it very well. Not outlining it very well, sorry. Here's an ovary down in there. Here's another ovary over here. And you notice this one back here looks rounder. Oops, I'm gonna erase that. So this one over here looked on the left, actually the right ovary looks round and smoother, I should say. And the one on the left ovary looks like it's got bumps on it or something like that. Well, actually, what that actually is you have, this is the right uterine tube over here. So here's a uterine tube right here. And these are the fimbriae that are over the top. And so that actually would be down over the ovary, and the ovary would release its egg into that, and those would wave the egg into the uterine tube, the fallopian tube. And so that's what you're seeing here is the top side of that. So that's the top side of the fimbriae, and then you have the uterine, and then you have the uterine tube going across here. And it goes in, then it goes back into then it curves in and goes into the uterus. Curves in and goes into bring my hands over, curves in and goes into the uterus there. So anyway, there's a nice view of the ovaries there. All right, next slide. So, last thing I want to talk about was performance enhancing drugs. Since we're talking about hormones, all that kind of stuff, what are they? Well, you have anabolic steroids, testosterone. You can use those to increase muscle mass. So Justin Gatlin, he's a runner for UT. He was a 100-meter sprinter. Marion Jones, she was a sprinter, and her husband, C.J. Hunter, who did the shot put, all denied taking androlone, which was nortestosterone. Although C.J. Hunter tested positive in 4 tests at over 1,000 times the limit of 2 micrograms per liter for a metabolite. The thing is, and that was called the Balco scandal. Metabolite is norandrosterone. Sorry, norandrosterone. You can't test directly for the nortestosterone, but you do test for the metabolite. So that gives a little bit of wiggle room. Like somebody could say, well, I just naturally make that metabolite. I don't actually, I wasn't actually doping. So, but Justin Gatlin got tossed out of track, as did Marion Jones and C.J. Hunter all got tossed out, and Justin Gatlin finally came back, and so he's still a fast runner. But I just remember seeing him run one right at the end of this thing, right before he got caught, and watching him run. His muscles were just massive on his arms and his chest. It was, and you're like, oh, he's got to be doping. So he's going to be taking testosterone. So other things that you can do. Androstenedione, is also called andro. It's a testosterone precursor produced by the adrenal cortex, ovaries, and testes, and that can be converted to testosterone. Another one is human growth hormone, thought to increase muscle mass, but nobody really knows for sure if it does that or not. It's kind of inconclusive. Lance Armstrong did EPO, erythropoietin, which increases the number of red blood cells in you. It's very popular with endurance athletes. You also, in order to mask what you're doing, you take a diuretic, which increases your urine output, and thereby you decrease the concentration of the PEDs that you have in your urine. So that's why it's called a masking agent. So And you can also use it to get an athlete down in weight, say for like wrestling. It's dangerous to do that, but people do that. Other things that are done, creatine, you might help cells produce more ATP, but hadn't really been shown to be effective or increase performance. And other things that do actually work are stimulants, such as caffeine and amphetamines, mild stimulants like ephedrine and pseudoephedrine. Problem with those is that you can increase the risk of heart issues and fibrillation when the heart is fluttering or beating too fast. And you can produce tachycardia, which is beating too fast, or fibrillation when the heart is fluttering. So you're not getting blood flow when you start exercising. So you got to be careful with stimulants. Caffeine. If you're used to taking caffeine in the morning and you go for a run, you're probably okay. But if you don't usually drink coffee or caffeine in Cokes or something like that, and you just go and get some, you will feel an effect of it. I went off caffeine a while back, and just to see what life would be like without caffeine. It's when I have a cup of coffee that has caffeine in it, it really it's like wow, I can really tell. So anyway, but those are performance enhancing drugs. Just thought you'd be interested in hearing a little bit about those. So all right, next slide. So all right, so there we are. We are done with the endocrine system. Yay! So next up will be the integumentary system, and that'll be the last one for the semester. And you guys will then be off on your own. So I'll leave with this little joke and have fun. So all right, and I'll see you at the integumentary system. All right, bye.